Till now, you have learned a lot of concepts. You know many Linux commands, we learned about scripting, etc. We also learned that you can have multiple users in a Linux environment, and these users can run programs and processes as well as execute different commands, etc. In fact, you can have multiple users on other operating systems as well, like Windows or macOS. So this multi-user environment is actually very common on all operating systems. So each user has its own environment where it works and executes stuff. And as you know, as a user, you can configure your space, your account basically on an operating system by setting different preferences. Maybe you want a certain graphic user interface layout. You want the font to be bigger, you want different colors, you can configure all of that. Maybe you also want to have a different shell program and not the default bash program. You want to configure a default editor when opening files. Or maybe you also want to set a web browser which is going to be a default for opening websites. You can configure all of that on an operating system, whether it's Linux or Windows or whatever. So when you make changes in the operating system configuration and set preferences, of course you don't want your configuration to influence other users on the system, because they might have their own preferences for all of this. So these environments, the user environments and the configuration and settings should be separate from each other. So how does an operating system keep track of these users and their environments? So where does it store all the information about how each user has configured their space? Operating system stores this information in what's called environment variables, which are basically pieces of information defined by key value pairs. In the bash scripting, you learned about variables. We have a name of the variable and the value that that name references. That's exactly how environment variables are defined. But these environment variables are available for the whole environment, not just for one specific script. And the keys or names of these environment variables by standard are defined with all capital letters. For example, each user has a set of environment variables that define that user's environment settings. For example, user variable that has a value of the currently logged in user, or home variable that points to the current user's home directory. And you also have variables that define users' preferences, like editor, which is the default file editor that's used when you open a file, or shell, which is user's default shell program. And as we learned, by default, Linux configures bash as a default shell program, but a user can change that to another shell program like Z shell, for example, right? So the value of shell environment variable will point to the path of Z shell instead. So as you see, a user can change these environment variable values. So they are set by the operating system, but you can change them. That's why we call them variables. They have dynamic values that can be changed. So let's see how you can access these variables in your system. We have a command for displaying all the environment variables that the operating system sets for that user's environment. And that command is printenv. If I execute this, you can see a list of environment variables, a bunch of them that system has set for us. We can also open them using less program, as we learned. We can basically view them like this. And as you see, there are a bunch of different environment variables. You don't have to understand and know each one, but here are some of them that I already mentioned. We have a shell variable that points to the default shell program, which is set to bash. We have the home environment variable that points to my user's home directory as well as username. We have a language that I have configured for my account, which is English. We also have the Linux user, and so on. We can also access individual environment variables using printEnv and then the name of the variable, like user, for example. And we get the value of that environment variable. So this way we can check what is the current value of a specific environment variable. If we have multiple environment variables that have similar name, we can print all of them by using grep command like this. And there you go. So this is basically how we can print environment variables using printEnv command. However, the environment variables can also be used by Linux programs or commands by referencing them with a syntax that we already learned in bash scripting, which is $ and variable name. And as I said, we can use that variable reference in different commands. For example, we can do echo and then variable name, and it will give us the value. In the same way, we can use environment variables, or we can reference them in bash scripts, just like you would a normal variable that you define inside the bash script. As I said, operating system creates these environment variables to store information about the environment. But this is just one use case of environment variables in an operating system, because they have many more usages. For example, we can also create our own environment variables in addition to what system already provides us with. Now, why would we want to do that? What is the use case of creating our own environment variables? Consider a program we want to run on an operating system. Let's say I want to run a Java application or a Python application on a Linux server with my user. And that application needs to connect to a database or an external API like Google Maps, for example. Such external services, like external databases, APIs, whatever, they usually need some kind of authentication so that not everybody can connect to it. So the application that I created that I want to run on the server will need username and password to access the database. Or it will need some kind of a secret token to connect to the Google Maps API so that the service knows this is that application that it can trust, right? Now, how can we tell that application in a secure way what these secret values are, what the credentials for a database or the secret token for the API is? Because we can't just write these values in the code of the application and check that into the code repository, because then other people may easily see that in the repository, plus it will be in plain text, right? That's not secure, so we can't put this information inside the code. So how do we store this sensitive data in a secure way, but also in a way that the application can access them when it runs on the server? And one very common way to do this is by setting such data as environment variables so that application can then read the values of those environment variables. How does it work? We basically create environment variables like database underscore username or database underscore password. And again, that's a standard naming convention for environment variables, all caps and underscore for separating the words. So we set these environment variables, and by creating these environment variables in Linux on a server, for example, we make them available in our environment or in our user's environment. And this means they become accessible for all the applications and processes that we run in that environment. Now, you're probably wondering, how does the application access those environment variables? How can it actually read? What is the code for that? Well, note that every programming language has a syntax or a library that allows it to access or read these variables from the environment where it's running. So every programming language basically supports that. Now, the environment variables we create for the application aren't only for storing sensitive data, but also for making the application more flexible. What do I mean by that? Our application will probably run in different servers. We might have a development server, which is our development environment for testing the application, maybe in development stage. Then we may have a testing server, and then we may have the production server. And each of these environments, like develop, test, and production, will have their own database. So we'll have a database for testing maybe, and database for production. So production database will have its own credentials, and external services or external APIs, they will also have production access token and testing access token. That's a basic standard when developing applications. So instead of hard coding these values in the application, using environment variables, you can dynamically set different values for your application and run it in different environments without changing the code. So when your application runs in a development environment, you can give it credentials to the development database. When it runs in production, you can give it, or you can pass in environment variables for production database and production API keys. And this makes your application much more flexible while also storing all this sensitive data in a secure way on that server where the application is running, so no one can access it. It's like providing parameters to your application, just like we provided parameters to our bash script. So as you see, environment variables are a very important concept in all operating systems. And it works pretty much the same whether you're Linux or Windows or macOS. Now let's actually see how to create our own environment variables. And this works pretty much the same on all Linux distributions, so nothing specific to Ubuntu here. So first of all, to create an environment variable, like db username, for example, we just define a variable name, again, all caps and underscore, and a value. The value is the actual username in the database. This could be called a db user or my app user, whatever. However, for this to be set or to be interpreted by the system as environment variable, we need to do something like export. So we are exporting a variable as an environment variable. And this is what makes it different to standard variables that we defined in a bash script, for example, because standard variables are only available in that script. Environment variables are available in the whole environment. And for that, we need to do export and then variable. We can also export db password, for example. Let's say it's some secret value that nobody should know. It's also very common to set not so sensitive data like database name or URL also as environment variables instead of hard coding that into the code. And as I said, because this way we can run our application in development, production, testing environments without hard coding these values inside the code. So db name, because the database name and database URL will actually be different for production database and for development or testing database. So this sets environment variables in our Linux environment. And now if I do print and filter on my environment variables that have db in it using the grep command, there you go. Printf prints environment variables, and 3 of them that we defined here are on the list. Again, if we want to use that in other Linux commands, for example, if we want to use that in a bash script or whatever, we can access them using $, and then name of that variable, like this. And again, because these are variables, we can also change the values of those environment variables once we define them. So maybe we renamed the database, so we can set db name to new db name, whatever that is. And we can also unset or basically remove the environment variable from the environment using the unset command and name of the variable, like this. Again, execute printf, and there you go. So once we set those environment variables that the application should read basically or access to be able to connect to a database, we can now run the application in this prepared environment where we have created the variables, and the application will be able to access those values. So right here you would run your Java application or Python application or whatever it is. However, there is one interesting point here when working with environment variables or when setting them. So I'm gonna close this terminal and open it again and do print env and filter for our DB values. And you see all those environment variables that we set are actually gone. They're not here anymore. So basically, and that is a very important concept to know, is that whenever we set environment variables using the export command on a command line interface, they are only available in this current session, basically, right? So in the environment of this specific session. And once we close that terminal, or even if we just open a new window, in this terminal, in this session, that environment variable will not be accessible. So these are not permanent environment variables that we can set using the export command. So how do we set environment variables permanently so that we don't lose them whenever we close the session? Well, for that, there is a file in each user's home directory. This is the home directory for my current user, and the file is called it's a hidden file, bashrc. So basically there is a file in the user's home directory created by or auto-generated for the shell program that your user is using by default. In our case, we're using bash program, that's why it's bashrc. If you're using, for example, Z shell instead, this will be Z shell rc. So basically whatever your shell program name is, it will have this rc file that holds the environment variable specific to your user. So if we open this, you see a bunch of code here. So whenever we want to permanently add variables that will be available in all the terminals, in all the sessions of our user, we need to add them in this file or in this RC file of whatever shell program is configured as the default shell for your user. So right here at the end of the file, we're going to do export db username and then password, some secret value, doesn't matter. Let's also set db name. And there you go. Now we can close this and save the changes. Now there is one more thing we need to do here, because if we now do printf, we don't see the values yet. So basically we have added those environment variables in our bashrc file. However, the system doesn't know about the change yet. So we are kind of reloading the system to take the changes from that file. And for that, we do source bashrc. So we're telling the program, hey, we changed something in that bashrc file. Please apply those changes. And now if I do printf again, there you go, we have our environment variable values. And now if I close the terminal and open it again and do printf, we have the values available. Now, whatever application or program you run in whichever session, these environment variables will always be accessible for all of those programs. Now, in our examples, we created environment variables for our user, right? So we configured environment for one specific user. What if we want to set an environment variable for all the users on the system? Well, in addition to the user-specific bash rc file or shell programs configuration file, in each user's home directory, we also have a system-wide environment variables file, which is located in /etc folder, which is a directory where system configuration is stored, and the file is called environment. And if I open this file, you see that we have one environment variable already configured here called path. So this is a globally set environment variable called path that has the same value for all the users on the system. So what is this path variable? It's basically a list of directories with executable or binary files in them. That's why you see the binary folders at the end of each path. So we have user local sbin, user local bin, etc. And each directory is separated by a colon. So this is basically just a list. And the way it works is that whenever we execute a command or a program on a command line interface, the system checks all of these locations configured in the path variable to find that commands or programs binary file and execute it from there. And that means whenever we install a new software like Java or Python or Node.js, whatever, the binary files of this software will get added into one of those locations, and that's why we're able to execute Java, Python, etc. commands on a command line interface, because the system knows where the binaries of that command is. And let's actually leave this file without saving any changes, :q exclamation mark, we're just quitting. So basically path is a very important variable, because thanks to that path variable, we don't have to do this every time we want to use ls command, for example. Instead, we can just do ls. So whenever we do ls, basically it looks inside the path variables list of directories for the ls commands binary file. And that means if we create an executable program and provide path variable with its location, so if we add the location here as well, we can run command to execute that program directly like this from anywhere in our file system. And since path is a global environment variable set for all the users, it will be available for all the users on the system. And it will be fun to try out this one example. So let's see how we can add our custom command or program to the executable path. So let's create a very simple welcome script. And we know the syntax already. We have our shebang at the beginning. And then we have, let's just add echo line here. Welcome to DevOps Bootcamp and user environment variable. And you see that we don't have the syntax highlighting here, this nice shell or bash syntax highlighting, because I created the file without extension, just welcome without .sh. So that's why, but it doesn't matter because it's just a simple echo example. And now, as you remember, we need to make this welcome file executable. So we add permission for all users for executing this welcome script like this. And now we can add this executable file's location to path variable, either globally, as we saw previously, or, and that's actually also an interesting use case, we can add this location to the path only for our user. How can we do that? Instead of changing that in the global environment file, we're going to change that in our bash rc file. Here we actually don't have a path variable, so how do we do that? Simply by doing path equals, and then we can reference the existing path variable, which is available for all the users. And we're gonna append /home/nana. This is a directory where our welcome command or welcome program is located. So we always need the location to the directory. So again, we are taking the existing path variable's value, which is the list of all the directories, and then we are appending our custom script's location at the end. And we're setting that back as a path variable for the system. And we don't write export here because the variable path already exists and is already exported. We're just changing its value here. So if I save this and quit, and let's do source bash rc. And now let's actually move to somewhere else where we don't have welcome script or welcome command. And if I do welcome, there you go. Welcome to DevOps Bootcamp and the Linux user that we referenced from environment variable. So again, path, or the purpose of path is that instead of me having to provide the absolute location or path to my program like this, I can just go wherever I want in my file system in the command line, and I can type in just the name of the program, and it will find it in one of those directories configured in a path. So these are some of the use cases and some of the really important usages of environment variables on an operating system. And we're going to be working with them throughout our bootcamp. So you will see plenty of realistic use cases and examples where we set and use environment variables for different applications.